Hello students, today we will start the last chapter of our computer networks. First, the chapter number 6, the medium access sublayer. As we have seen already the first chapter, according to the transmission technology, networks are divided into the two major categories, that means point to point connection, and second one is the broadcast channel. In point-to-point network, dedicated links are reserved for the communications, whereas the broadcast networks, all stations share a single communication channel. Here the medium access sublayer having these topics. First one is the random access protocol, allow pure and slotted. Then second is CSMA, one persistent, P persistent and non-persistent, CSMA CD and CSMA CA. Then control access reservation, pooling and token passing and channelization, FDMA, TDMA, CDMA, analogy idea chips. Then data representation, encoding and decoding, signal level sequence and generation. Then here the introductions. The data link layer is divided into sub layers, that means the logical link control LLC and medium access control MAC layer. The MAC layer provides addressing and channel access control mechanism that make it possible for several stations to communicate within a multiple access network that incorporate a shared medium, for example the Ethernet. Then many formal protocols have been devised to handle access to share link. We categorize them into the three groups. First one is the then protocol belonging to each groups are as first is a random access protocol. In this type of protocol, any stations can transmit at any time, and use of this channel is not controlled by any station. Then second one is the control access protocol. In control access, some sort of mechanism is used to decide which stations can transmit. And the third one is the channelization. In channelization, the available channel bandwidth is shared either in frequency, time or code. Here the multiple access protocols having three types. First one is the random access protocol, second one is the control access, and third one is the channelization protocol. Here the channelization random access protocol having the Aloha, CSMA, CSMA CD and CSMA CA. Then the control access protocol having reservation, pooling and token passing, and the last one is the channelization having FDMA, TDMA and CDMA. These are the categories of the multiple access protocol. Then the channel allocation problem. The main problem for broadcast channel is how to allocate a single broadcast channel among several users. There are the two schemes which we will understand. The first one is the static channel allocation in LANs and MANs. Then second one is the dynamic channel allocation in LANs and MANs. Then first one is the static channel allocation in LANs and MANs. The traditional way of allocation the single channel for multiple user is the frequency division multiplexing, that means FDM. If there are n user, the bandwidth is divided into n equal size portion and each user is assigned to one of the portion. Since each user has a private frequency band, there is no interference between users. When there is only a small and fixed number of users, then FDM is a simple and efficient allocation mechanism. Then when the number of senders is large and continuously varying, then FDM is not suitable in those situations. If the total bandwidth is divided into n regions for n users, and if fewer than n users are communicating, the large piece of valuable bandwidth is wasted. If more than n user want to communicate, some of them will not get the permission of lack of bandwidth. Because of the disadvantages of static allocations, we need better scheme for LANs and MANs. Then second type is dynamic channel allocation in lands and mans. Instead of reserving special frequency band for every user and limiting the number of users, the channel is allocated dynamically, which can be used to transmit the data for any number of user and at any time. For dynamic channel allocations, we will make some assumption. First one is the station modem. This modem consists of n independent stations and each with the user that generate the frame of transmission. Then once the frame has been generated, the station is blocked and does nothing until the frame has successfully transmitted. Then second one is single channel assumption. A single channel is available for all communication. That means all stations can transmit or receive from it. Then third one is the collision assumption. If two frames are transmitted simultaneously, they may overlap and result into the garbable signal, and this event is called as the collision, and all stations can detect collision, and these collided frames are retransmitted. Then fourth one is the continuous time. The frame transmission can being at any instance and there is a no master clock dividing the time into the discrete intervals. Then fifth is slotted time. The time is divided into the discrete interval, that means slots. The frames transmission always begin at the start of the time slot, and one time slot may contain transmission of many frames. Then sixth one is the carrier sense assumption. The stations can tell if the channel is in use of before trying to use it, and if the channel is sensed as busy, then no stations will be attempt to use it until it becomes ideal. And last one is the no carrier sense. Stations cannot sense the channel before trying to use it, and instead it just transmit and after some time determines whether or not the transmission was successful. Then the next topic is random access protocol. In random access or contention method, each station in the network has equal right. No stations is superior to other stations, and no station permit or does not permit another stations to send. All can have direct access to the medium through which the information or data flows, and the individual stations is not controlled by any other stations. At any instance of time, stations which want to transmit data uses a procedure defined by protocol and decides whether to transmit or not. This decision depends upon whether medium is free or busy. Then random access protocol has two features. First one is that there is no schedule time for the stations to transmit. Transmission is a random among the stations. Then second is no rules specify which station should send next. Then stations compete with one another to access the medium. So these protocols are called as the contention methods. Even though if more stations tries to send frames, then there may be conflict is called as the collision occurs, or frames may be destroyed or modified. To avoid the collision, modifications, etc., we have evolution of the random access method. Here the evolutions of the random access methods. To avoid these collisions, which handles the some situation properly, and it will help us to answer from the questions like the when stations can access the medium. Then if the medium is busy, then what stations can do? If the collision occurs, then what stations can do? And how stations get informations about the success and failure of the transmission. To answer this type of questions, we have evolutions of the random access method. These are seen in these figures. Here the multiple access MA. Then here the aloha, there are the two types, pure aloha and slotted aloha. Then CSMA, carrier sense multiple access, having the two types, CSMA CD, that means collision detection, and CA for the collision avoidance. In this case, multiple access is a simple procedure called as the aloha, and this method was improving with the addition of protocol procedure on the basis of the sense the medium before transmitting. This is called as the CSMA, that means the carrier sense multiple access, which has the two parallel methods. First one is the CSMA CD and second one is the CSMA CA. First is the CSMA CA is for the collision avoidance, which defines a procedure for avoid collision, and second one is the CSMA CD is for collision detection, which defines if collision is detected. Then Aloha is a system for coordinating and arbitrating access to shared communications network channel. Aloha was developed in the 1970s by the Norman Abrahamson and his colleagues at the University of the Hawaii to solve the problem of channel allocations. Aloha was designed for a wireless LAN, but it can be used for any shared medium. The medium is shared between the stations when a station sends the data and another stations may attempt to send data same time, and it is obvious that the data from the two stations collide and destroyed. There are the two types of the Aloha protocols. First one is the pure Aloha and slotted Aloha. As discussed, first one is the pure Aloha. Here the original Aloha protocol is called as the pure Aloha, and the concept of Aloha is very simple. To each station send a frame whenever it has a frame to send. Then the since there is only one channel to share, there is a possible of collision between frames from different stations. Then the figure shows example of frame collision in pure Aloha. See, this is the figure. Some of the frames collides because multiple frames are in contention for the shared channel. Here the example, see the figure having 4 stations are shown. Then station 1, 2, 3 and 4. Every station send a frame on the shared medium, and some of these frames collides because multiple frames are in contention for a shared channel, and only two frames, that means frame 1.1 and frame 2.2 survive, and all other frames are destroyed. Then in pure Aloha, whenever any stations transmit a frame, it expects the acknowledgement from the receiver, and if the acknowledgement is not received within specified time, the stations assume that the frame or acknowledgement has been destroyed. Then if the frame is destroyed because the collision, the stations wait for the random amount of the time and send it again, and this waiting time must be random, and otherwise same frames will collide again and again. Therefore pure Aloha dictate that when the timeout period passes, each stations must wait for the random amount of the time and before resending its frame. This randomness will help avoid more collision. And the pure Aloha protocol has a second method to prevent congesting the channels with a retransmission, as shown in this figure. See the figure. A node or station send the frame and then wait for the period of time which is the 2 times maximum propagation delay. If the acknowledgement is received, the transmission is successful, and if the acknowledgement is not given, the station has to use the back off strategy and send the packet again, and after several tries it is not happen, then procedure is aborted. And here vulnerable time is calculated as here the pure Aloha vulnerable time is 2 into T FR, and throughput, let G is the average number of frames generated by the system during the one frame transmission time. Then average number of successful transmission for pure Aloha is S is equal to G into E minus 2G, and the maximum throughput of pure aloha is 0.184. That means not more than 8.4%. Then second type of aloha is slotted aloha, and important to the original aloha protocol was slotted aloha, and which introduce discrete time slot and increase the maximum throughput. Slotted aloha was invented to improve the efficiency of pure aloha, as chance of the collision in pure aloha are very high. In slotted aloha, the time of shared channel is divided into the discrete intervals called as the slot, and the stations can send a frame only at the beginning of the synchronization time slot, and only one frame is sent to each slot. And then in slotted aloha, if any stations is not able to place the frame onto the channel at the beginning of the slot, that means it misses the time slot, then the stations has to wait until the beginning of the next time slot. And in the slotted aloha, there is still possibility of collision if two stations try to send at the beginning of the same time slot, as shown in this figure. Slotted aloha has still an edge over pure aloha, as the chance of collision are reduced to one half, and slotted aloha requires global time synchronizations. Then carrier sends multiple access.